Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping back into an 8th grade topic, geometric rotations. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. At the end of this video, I'll be linking my 8th grade playlist in which I cover a ton more topics. So, if you're interested in that, make sure you stay tuned. As always, if you have any questions about what we see today or even on homework, you can always put in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video will have 3 parts, so leave a like, smash subscribe, and let's get started. Last video was getting pretty long, and we still had a few things we need to cover when it comes to geometric rotations. Thus, we're back with the part 2. In our last video, we covered notation, and we even rotated a single point the long and short way. That short way being our shortcut that we developed at the end of that video. If you hadn't caught that video, no worries. I have a link to it right up here. You can check it out at any time. And I actually recommend that so you have a little bit more background, because this video is not going to be really doing all of that again. We're going to kind of start from that shortcut and then use that shortcut. So if you want any of the background and why it works the way it does, I recommend checking out that video, part 1. So like I said, we're going to be using that shortcut to handle our 2 examples for today. In our first example, we're going to rotate an actual figure. Since we only did 1 point around the origin in our previous video, I want to show you just how simple it is using our shortcut to rotate an entire figure about the origin. In our second example, we're going to be doing something a little bit different. So far, we've only talked about rotating about the origin. However, we never talked about what happens if you need to rotate about another point besides the origin. So we're going to cover that in our second example. But before we can do that, we still need to do a quick recap of the notation and our shortcut that we developed so we can use that for our first example. If you recall, the notation for geometric rotations was as follows. We had a capital R and a subscript number here. So let's say 90 degrees. This is our degrees in which we're rotating. And we had a sign or an absence of a sign. If there's no sign, it's positive. If it's a negative, you'll have that little dash there. And that tells you your direction. And we had not only 90 degrees of rotation, we had 180 and we had 270. And that plus, if you recall, was our counterclockwise rotation. So we had our clockwise rotation, which needed our negative sign there. So we had these type of notation that we covered in our last video. You may also recall in our last video we covered equivalencies. Some of these rotations are the same as the other, but which ones are they? Well, it's not in this order. So let's redo it with the equivalencies mapped out. In that case, we're going to need our negative 270 here and our negative 90 down here. These are going to be equal to one another. This means that as long as you can find one, you can find the other. Regardless of which one they actually ask for, you can always find what you're looking for. So assuming you're starting at the point x, y, we also discussed a shortcut that told us how each and every one of these rotations was going to affect this point. We found out that a 90-degree rotation was going to affect the point x, y in the following way. You're going to have a negative y, comma, x. So you're swapping your x and y's and you're negating the y when you do so. Our 180-degree rotation is going to affect it in the following way. You're going to have the same x, y, however, you're going to negate them. And our rotation of 270 is going to affect it in the following way. You're going to have the y and your x swapping, however, the x is going to be negative. So this is the shortcut we found for each one of these rotations. So we're going to use our knowledge about these equivalencies and our knowledge on this shortcut to attack our first example. Let's jump straight in. So this is our example 1 for today. We have this triangle ABC, and we're going to rotate it clockwise 270 degrees. So the first thing we need to do is determine what points we have for this figure. So we know A is going to be located at 1, 4. So A is going to be 1, 4. B is going to be 2, 2. So B is going to be located at 2, 2. And C is going to be 3, 3. So C is going to be 3, 3. And we're going to be rotating about the origin here. So this point of origin is where we're going to be rotating, whether it be counterclockwise or in this case, our clockwise rotation, since it's a negative 270. So now that we know what points we're starting at and we know what type of rotation we're going to do, let's figure out what equivalency we're going to be needing and which part of the shortcut we're going to be needing. So since we're rotating clockwise about the origin, we have to go all the way here. 270 is going to push us all the way in quadrant 2. Now, do we want to do all that work the long way especially? No. We want to do a shorter way, right? A shorter way. Well, first, what equivalency puts us in here? That's going to be a rotation of 90 degrees in our clockwise fashion. And what part of the shortcut gives us 90 degrees in our clockwise fashion? Well, that means we're going to be applying the negative y x shortcut, right? So if we start at xy, we're going to apply the negative y x shortcut to give us what we need in this quadrant. So I'm going to rewrite this down here to make sure we have enough room to draw whatever we need to draw in our second quadrant. So now that we have some space, let's figure out what our a prime, b prime, and c prime is going to be by applying this shortcut here. So a prime tells us that we're going to be swapping y and our x, right? So this is going to be a 4 and a 1 here. However, we have to negate the y. So it's going to be a negative 4 and a 1. Our b prime is going to be 2, 2. Well, it's the same, so swapping it doesn't really do anything, but we do need to negate that 2 in the x quadrant. And how about c? C prime is going to be the same thing. Negative 3, 3, because they're both the same. So swapping doesn't do anything, but you do have to negate that new x. So now that we have our 3 points, let's graph them. So a prime is going to be 1, 2, 3, 4. So negative 4, 1. So that's right here. B prime is going to be 1, 2, 2. So that's going to be right here. And then C prime is going to be 1, 2, 3, 1, 2, 3 up here. So if we connect all these dots, this was C prime, this was B prime, and this was A prime, right? We get this figure here. Now, we're rotating this way if you do the 90 degrees, or we're rotating all the way this way if you're doing the negative 270. However, they give us the same figure. This is how you apply not only our equivalencies, but our shortcut to easily rotate a figure about the origin. So now that we talked about how to rotate this figure about the origin, let's talk about what we need to do if we want to rotate this figure about a point other than the origin. So in order to rotate about a point other than the origin, the first thing you need to do is shift everything back in reference to the origin. Now, what do I mean by that? Let's say we have this point negative 1, negative 2. What do you need to do to get back to the origin from that point? That means that this would need to add 1 and add 2, and then that's going to give you the point 0, 0. So we're shifting this point back to the origin. But I want you to think about equations. Whatever you do to one side, you have to do to the other to keep things balanced, right? Well, although this is not necessarily an equation, whatever you do to one part of what you see here, you have to do to the other part. Well, what's the other part? If we've moved this back to the origin, what else do you think we should be moving? Our graph here, our figure. Well, we're going to move this back to the origin, and we're going to move this the same distance. So we're going to get a new ABC. It's not quite A prime, B prime, and C prime, but it's going to be our middle step. So I'm going to call it A bar, B bar, and C bar. So it's the middle step. So A bar becomes 2, 6. B bar becomes 3, 4. And C bar becomes 4, 5. Now we've shifted everything back in reference to the origin. We're no longer focused on this random point here just yet. We'll come back to it. But now we're going to be focusing on the origin and do the same exact thing that we have been doing all along. We're going to apply our shortcut to get our new points. So if we were to rotate negative 90, that's going to be equivalent to rotating 270, right? A positive 270. And what's going to be our shortcut for rotating a positive 270? Well, we're going to have X and Y swapping again, right? However, this time we have a negative X here. We're not going to have a negative y like we did in the previous example. We're going to have a negative x here. So we're going to apply this shortcut to our a bar, b bar, and c bar. And when we do that, we're going to get the following. I'm going to call it a bar prime, right? And I'm doing that for a reason. We have some middle steps we have to cover. So a bar prime, b bar prime, and c bar prime. So we're going to technically rotate these points, but we're not going to be done yet because we have one more step to do afterwards. So if we apply this shortcut rotation to these points, what do we get? So first we're going to be swapping x and y. So a bar prime becomes a 6, 2 here. However, we need to negate that x, so that becomes a negative 2. Our b bar prime becomes a 4, 3, but we need to negate this 3. And our c bar prime becomes a 5, 4, but we need to negate that 4. All right, I said there was one more step, and that step is we need to shift everything back to our original point. We had these middle steps, which were very helpful, but we don't want to rotate about the origin. No, we want to rotate about the point -1, -2. So we need to reverse what we did to get things in reference to the origin to now have them in reference to our point. So we added 1 and added 2, right? Added 1 to our x, added 2 to our y in order to shift it up. Now we got to do the reverse. Subtract 1 and then subtract 2 from our x and y respectively to get it back here. However, I'm going to need a little bit of space here, so I'm going to erase this intermediate step that we're no longer needing. However, I want you to keep track of everything you've been doing. So if you need to rewind this video to figure out what we did, don't lose track of what we did to get to our final answer. But because my board space is very limited, forgive me. So now that we're going back to our point of interest, -1, -2, we can actually do our a prime, b prime, and c prime because we're actually finding the rotation of the original points. We're actually going to be doing the rotation now. So there are no more bars. Those were our middle steps. We don't need those anymore outside of referencing this to now subtract a 1 and subtract a 2. So I should probably write that. We need to subtract 1 and subtract 2. So we're going to apply that to both of these and do the same thing for each one of these points. So when we subtract 1 from that 6, we get a 5. And we subtract 2 from this -2, we're going to get a -4. Likewise, subtract 1 from this 4, you're going to get a 3. Subtract 2, you're going to get a -5. In the same fashion, subtract 1, you're going to get a 4. And then subtract 2, you're going to get a -6. So looking at points a prime, b prime, and c prime, it seems like our final graph, our rotation, is going to end up in our 4th quadrant. We have successfully shifted everything back down, and we're going to end up right in here. So now I'm going to remove this so we can kind of shift over our a prime, b prime, and c prime and elongate this x just a tad bit more to make sure we have enough room to graph our graph. So now that we have a slightly longer graph, let's plot our a prime, b prime, and c prime to see what our graph looks like. So a prime is 5, -4. So right in here somewhere. B prime is going to be 3, -5. So there's going to be 1, 2, 3, 4, 5. So down here. And C prime is going to be 4, -6. So this is going to be all the way down here. And then we're going to connect these dots. This was our A prime, B prime, and C prime. So although we've removed our middle 2 steps, we see that we start at 1, 4, 2, 2, and 3, 3, and we go all the way to 5, -4, 3, -5, and 4, -6 when we're rotating about the point -1, -2 with a clockwise 90-degree rotation. So I hope you are following today's examples, and I hope you see that rotating your whole figure, whether it be about the origin or even about a point other than origin, It's not going to be that difficult. As long as you understand your basics, if you can rotate a point, you can do an entire figure. However, if you have any questions about what you saw today, or even on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope it's helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.